Williams.
And I'm Billy Thomas.
And welcome to another edition of From the Woods Today.
Happy Insect Week, Billy! Woohoo! I know some people are gonna like, but insects are very beneficial to us.
Oh, I know. I'm so excited about today's show. We've got really one of our favorite guests and our
We've adopted him.
Yes, I know, our resident entomologist, Dr. Jonathan Larson, but he's going to be talking about kind of this wonderful world of insects, and our forests have all kinds of creatures in them, right? Including a lot of insects. But, we always appreciate Dr. Larson. He really gives us the insight in this world that really many of us don't know much about.
No.
And like you said, Renee, some people may be a little apprehensive about some of this stuff, but
Some of them.
yeah, but I'm really excited to have Dr. Larson on. If you have questions for Dr. Larson today, please use our chat function and we'll get to you there. If you are a YouTube listener or a podcast listener, thank you. And you can hit us up via email at forestry.extension@uky.edu and we'll get to you there. Well, also on tap, we do have a tree of the week. Laurie's got one for us. I'm queued up, so we'll get to that after Dr. Larson. But Renee, great to be with you today. Everybody, please be safe out there. It's so warm this week. You look out for each other, really.
Definitely. It's this heat is, I should have probably had a show on what not to do in your woods with the heat going on. But let's go ahead and get this one started though. Dr. Larson, welcome to the show again. Like I said, so
oh man,
I can talk about hydration if you would prefer. I mean, it is very important right now. It's like a wall of humidity out there.
I'm telling you, I don't know if there's anything you can't talk about, but we're excited to have you talking about insects today. That's for sure.
Yeah, do bugs sweat? That might be wrong.
Interestingly, no, bugs do not sweat due to their exoskeleton. So all their moisture stays inside, and they have a hard time regulating their body temperature.
Yeah, well, hopefully they don't boil. So
right now, yeah, they're hiding out probably under a lot of logs and things in the forest, trying to find that cooler area.
I don't blame them.
The cool side of the pillow, kind of.
There you go. We all like that.
Exactly. All right. So you're talking about the insect realm today and all things insects.
That's the plan. So Renee said it earlier that this is the internationally recognized the Week of Insects. For me, every week is the Week of Insects just because of the nature of my job. And Renee invited me today to talk a little bit about the world of insects, to talk about what they are and kind of their place in the world. I'm going to adapt my charge a little bit, I think, and also talk a little bit about their interactions with us, because frankly, it's hard to talk about insects without sort of putting them in the place of the kind of cultural milieu that they exist with humans, just because we are, I don't want to say locked in a Cold War with them, but it feels like that is kind of the idea that's in a lot of people's heads nowadays, is that insects and humans are kind of diametrically opposed, and that has a lot of consequences for their populations and for the world at large. And so I'm going to kind of try and unspool that history a little bit of our interactions with them and talk a little bit about where we're at with insects and the challenges that they face. But to start, I just wanted to talk a little bit about what they are and why people like me dedicate their lives to them. This is the most biodiverse group of animals that exists on the planet. We have more than 1 million species that have been identified. There are so many different kinds of insects. The most biodiverse group of insects themselves are the beetles, and you can see a smattering of beetles here on the screen. This is just a few different families of beetles that you could find in your backyard. You probably won't find any of these really big and showy insects here in Kentucky or even in the eastern United States. Some of them are native insects, but a lot of these are sort of metallic jewel beetles from the Central and South American areas. But we do have some similar looking insects here. So we've got some lady beetles mixed in. You can see the spots over here on the side. We have some scarab beetles mixed in, the more round ones. You can find lots of really interesting dung beetles and other scarab beetles here in Kentucky. I've talked about big beetles on the show before. Other insects in here include some weevils. The metallic jewel beetles I mentioned are kind of the long exclamation point looking ones. There's some click beetles mixed in. There's just all different kinds here. And then when we look at all of the insects, this biodiversity, it's almost hard to fathom. We're just one species. And then when we look at them, there's literally 1 million or more than 1 million different kinds of them. And it's almost impossible, I think, to wrap our head around just the sheer number and diversity of them. And I think further that's complicated because there might be so many more left to discover. This chart is from the 70s, so it's a little out of date, but it's also very evocative, I think, of what the arthropod, the insect world kind of looks like in comparison to other life. If you look here, there's flowering plants and then ferns, mosses, and gymnosperms, Dr. Crocker's favorite fungi mixed in there, and then some of the smaller life. And that's a pretty big piece of the chunk of pie here. But in comparison to the arthropod side, the insects, starting with the beetles, which we call Coleoptera, then the butterflies and moths and Lepidoptera, Hymenoptera, the wasp, ants, and bees, Diptera, the flies, Hemiptera, the true bugs, other insects, this represented by a mayfly here, and then the other arthropods, which include ticks and spiders and scorpions, as well as centipedes and millipedes and some other things. If you can kind of agglomerate them together, you're talking about 65% of life on our planet is represented on that side of the pie. That's the slice of pie that you want at Thanksgiving, is the arthropod sized pie slice, because it's just so big. And if you compare it to us, we're represented by this little fishy up here. We're the chordates, we're the things with spines. And so it's just this little tiny sliver. It's really important, I think, to remember that we are just one thing that exists on this planet. And I think that sometimes insects and other arthropods, they help us to be reminded of that. I've spoken on this a couple times, especially during the cicada emergence that just happened. It's this reminder that we're not as in control as we necessarily always think we are, and that there is life that exists here that's not really under our jurisdiction. And this, I think, helps to evoke that. It shows you just how small we are, not just in the universe, but even on our own planet. The competition that we face, the amount of other animals that are here, and a lot of them are these multi-legged, sort of hardened creatures that we call arthropods. The other thing that's important to talk about with insects is that they're basically everywhere. If you travel anywhere in the state of Kentucky, you will be no more than probably a foot or a few inches away from an insect. This includes all of the different terrestrial environments that we can find on Earth. So from our forests that we enjoy here in the eastern United States, up into places like the tundra and semi-frozen areas. The desert is also home to a great deal of insects. There's a lot of them that have adapted to be able to find shade and cool areas. A lot of them that are used for food by lizards and other things there. They visit cacti and all kinds of stuff in that realm. The greatest biodiversity of insects we see is in the rainforests, kind of in the central equatorial area across the planet. The insects are able to survive there because of warmer temperatures, higher humidity, and then a great deal of plant life that's there as well. Insects are not just terrestrial, though. It's important to point out that they are aquatic insects. Some insects are what we call semi-aquatic, so they spend half their life in the water. This would be things like a mosquito. Their larval form lives in the water. The adult form is airborne. Other insects, they spend their entire life in water. I've talked on the show before about diving beetles, which are an aquatic species of beetle. We could also talk about pond skaters, back swimmers. There's all different kinds of insects that have decided to use the water as their home all year round. But others, they're going to use it just sort of as a nursery. That's where they lay their eggs and their immature forms are able to develop there, kind of semi-protected from the world above. They are not limited to these sort of natural ecosystems, though. Insects have adapted to all the different ways that we have, quote unquote, kind of tamed the planet. When we think of humanity, we often think of kind of our dominion over nature. We think a lot about how we go to an area and we change it and adapt it to our needs. And insects are some of the animals that have adapted to that the best. So, for example, if you go through and remove a wooded area and then replace it with an acreage of corn or other sort of managed row crop or growing system, that's not a very natural setup. It's not normal for a plant to grow in neat little rows that a combine can drive between, but we do that. We put that out there, and insects are able to see that and say, oh, well, that's, if you're a corn rootworm, you look at this picture, you're like, oh my gosh, it's everything I need. It's dirt and soil and also the plant that I want to feed on. It's a giant Las Vegas style buffet and hotel for them. It's really hard to fault them for taking advantage of this, but lots and lots of insect species have done that, which puts them into contest with us. And then has some consequences that we'll talk about here in a moment. The other thing that I like to point out is that the average American home is actually quite buggy. This is something that some people don't like to hear, But no matter kind of what level of cleanliness you maintain in the home, no matter how new the construction is or how old your home is, the average American home has about 100 species of arthropods that survive inside of it. The diversity is different house to house. Some houses have more ants, some houses have more flies, some houses have more spiders, but there's always about 100 different kinds that live in there. Most of them you never see, most of them you never really encounter. They're living in the wall void or the crawl space, they're down under the basement, places like that. They've just adapted to these ecosystems because our houses are kind of nice deluxe heated caves or cooled caves that they can survive in. Some insects, they only exist in these sort of areas now. The house centipede, the German cockroach, the cellar spider. A lot of these, you don't really see them in the wild anymore. They basically only exist within the human home. And this just means that our houses aren't inherently toxic caves that nothing else can survive in besides us. There are some that, of course, become pests in this situation, but by and large, you never really notice them. So they've adapted to all of this as well. The only places you really aren't going to encounter an insect would be at the tops of our highest mountains. So the Appalachians are quite buggy, but if you went to Kilimanjaro or Everest, we don't see a lot of insects in those kind of low oxygen environments. And then we don't really have insects in the oceans. The oceans are the domain of some of the precursors to insects and some of their kin, what we would call the crustaceans, which we'll talk more about here in a second. Crustaceans, if you wanted to get sort of inflammatory for the shrimp industry, shrimps is bugs. Like they're just insects that live in the ocean. They're the insect kind of things that we are willing to eat, that we put a premium on and slather with butter or cocktail sauce. The crustaceans are not very different from insects. There's a lot of similarity. They're just bigger and meatier, and so I think it's a little more acceptable in some cases to consume them. But they're the ones that kind of use the ocean as their domain. Despite this kind of ubiquity in the world, the fact that they're present basically everywhere, the fact that we can encounter them at any point in time during the day, I would argue that insects are generally pretty poorly understood. Most people aren't curious about insects. There's a stage in life, sometimes during childhood, where people are interested in them. But I would argue that a lot of people kind of push that out of kids. They tell them that these are dangerous. We shouldn't interact with these. We don't teach a lot about insects in primary or middle or high school. Some people might take an entomology class if they attend university, but by and large, it's not something that people are wanting to experience. It's not something that they want to seek out and learn more about. And I actually feel like I see this pretty prominently in online spaces. This is just a couple of different memes I found on Facebook over the years. One says it's an insect field guide, and all the insects there have these sort of terrible names: the gross face, the devil spawn, the terror crawler. Somebody called the butterfly a flutter jerk, which I think is kind of funny. But when we see that, it's funny. The spiders, I think they get it worse. If you look at them on the other side, it just says smash it, set it on fire. I don't know if I can swear on here, so run like heck, set it on fire, shoot it. Some very American responses to this. Uh, they see these spiders, they don't like them, and so people respond very negatively to that. And it is funny, and I think it's very universal. Lots of people feel this way, but it's not great, I would argue. I understand why people react this way, and I'm not saying this just as an entomologist who likes insects and spiders and things. I'm saying it sort of as a person that exists on the planet. It's not great that we have one of the largest groups of animals that exists on our planet, and they're all just sort of lumped together as bad. And they're all terrible. They're worthless. They have no impact that can be good. All that, and that trickles into a lot of things. It becomes a problem for things like policy making. If we look at the endangered species list, it's heavily dominated sort of in a skewed way by woodland, furry, feathery, lizard-like creatures, all those different things that people like a little bit more than insects. I think there's only about 25 or 30 species on there that are endangered insect species, even though there's way more insects out there than those other things. There's also an impact on pest control. People will make choices for pest control that are, I don't want to say irresponsible, but they're sometimes not necessary because they just assume that all these insects need to die. They need to go away, and they'll pay money, they'll expose themselves to things in ways that are dangerous just because that's kind of this baseline mindset is, they don't exist. They shouldn't exist. And then all of that adds up to problems for environmental conservation. Insects don't usually factor into people's environmental conservation plans. They're not necessarily at the top of the list. There are some people who want to conserve butterflies and bees. We're seeing more and more firefly conservation occur, but typically insects are pretty low on the ranking list when it comes to things that we want to preserve. And it's sort of born out of all of this hatred that they face. I think that it's important to point out that most insects, they're really not going to impact our lives one way or the other. They are just neutral organisms that are trying to exist on the planet. They want to find food. More importantly, they want to find one another and mate and then create the next generation of their species. But they're not doing things necessarily that humans directly profit from. They're also not doing things that we're directly going to suffer from. My two examples here, if you've ever heard me at a Master Gardener class or a Master Naturalist class, you've heard me say this before, but on the left, we've got a stonefly. Stoneflies are insects that, as immatures, they live in creeks and streams. I don't think many people are sitting awake at night wondering what the stoneflies are up to. They probably don't even know what stoneflies are. They don't know that they exist. And I think that's important to point out. It's important to realize that so many of these insects that exist, you don't really know anything about them because they don't come into our life. Unless you're a fly fisher or somebody that owns a woods and you're going out and experiencing these things, you could live your entire life without ever encountering one. The same is sort of true of things like ground beetles. They're everywhere. They live all around you in the lawn. They're under all of your paving stones and rocks and logs at your house, but you're probably not going to interact with them very often. Sometimes they help by eating snails and slugs. Sometimes they get into your basement or your garage because they're seeking a cooler or warmer area, but they're really not doing anything. They're not harming the structure. They're not biting you. They're not laying eggs on you or anything like that. They're just kind of trying to exist. And so it's important, I think, to keep that in mind. I know that we are a somewhat selfish species. We like to think about how these things help us or harm us. But in most cases, they're just there. They just are living. If you walk away, you'll probably never see it again. There are pests. I'm not going to stand here on this show and say, oh, they're all great. Every insect deserves a chance to live. There are things that unfortunately cause harm. I would point out that pests are not inherently insectoid. There are pest creatures that have spines. There are pest plants. There are pest diseases as well. But for a lot of people, the word pest is kind of synonymous with insect. These are things that attack our crops, our food, our livestock, our home, or our person. I would argue only about 1% of the total insect population we would consider serious pests. That's still a big number, 1% of 1 million, right? But a lot of these are things that we contend with because they're invasive. My example here is the Japanese beetle. There's another about 3% of insects that we would consider minor pests. My example here is a green June beetle, occasionally a fruit pest, occasionally an annoyance in the summer, but really not a big deal. Usually kept in check by natural enemies and other natural forces. Not something that we have to have huge spraying programs for and an IPM program in place to try and deal with. That leaves the other 96% of insect life to be considered either beneficial or to be that kind of neutral thing that I was talking about before. We talk about beneficial insects a lot in entomology. We try to hype them up and get people to recognize, insects do so much for us. They're so good. They're so helpful. I would say beyond kind of our conceptions of benefits or harm for us, the roles that they play, they're just incidentally helpful to humanity. They are doing these things because they're keystone elements within ecosystems that exist beyond our grasp. So when we talk about natural enemies, we're talking about predaceous insects that exist because they eat aphids or other pests that we don't want to have around. But that's something they're doing because that's the role they play in the environment, not necessarily to be helpful and in our back pocket. Pollinators are, of course, always lifted up because we get fruit and vegetables out of their work, but they're also there to just be there for the flowers. They're there to help trees to bloom and have new seed set so that we can have more trees in the future. It's just a role that they have sort of graduated to in the environment over a very, very long time. The one that I think gets left behind the most and not considered very often are how insects are such helpful things when it comes to decomposition. Insects help to clean up all different kinds of poo. This is a dung beetle rolling a dung ball. They help to break down rotten wood, rotten plant material in the environment. Fungi and bacteria, they of course do so as well. But insects are very key in this process. Without them, we would be surrounded by so much more waste, and it would be piling high and stinky. And it's helpful to have them around. These roles that they play, they are beneficial to us, but it's important, I think, just to keep in mind that it's not about us necessarily. It is just the thing that they do. I hope that we'll appreciate that during Insect Week and beyond. But it's just part of the bigger picture that they are one single element of in nature. They are a part of what we call the arthropods. So Arthropoda is a phylum of animals that we generally call the arthropods in conversation. This just, I hope, will give you a little more context about insects and what they are, how they exist on Earth. Insects are just one representative class within the arthropods. So their closest living relatives are things like millipedes and centipedes, which we call the myriapods. Myriapod means many feet, lots of feet. So you can see why they're called that with this giant millipede here. This red thing is a large mite, a berry bug, some people call it. This is a representative of the arachnids. Arachnids include ticks, mites, spiders, and scorpions. They are close relatives to the insects. And then the crustaceans, as I alluded to before. Crustaceans are probably from where the insects came. If we look at the fossil record, all of these have multiple legs. They all have exoskeletons that sort of encase their body. They all have different sort of sensory appendages, but many of them have antennal structures and things like that. This is how we sort of group them together and know that they are relatives. This is just a basic chart that I use for teaching about kind of what arthropods look like. If you zoom out a little bit, you see the insects, the crustaceans, the myriapods there on one side of the fence. They have what we call mandibles. On the other side, we have things with chelicera. That's mostly the arachnids now. This is just a difference in the kind of mouth that they have, how they actually interact with their food, and where the mouth exists on their head. I'm not going to go into too much detail about that, but this, I think, just puts them in their place. It shows you what they're related to, where they came from, and kind of how we help to separate them. The way that we know something is an insect is based on these traits you see at the bottom of the screen here. So insects, they're part of insecta, sometimes hexapoda, depending on which guide you're looking at. Insecta means cut into sections. It's all of the insects. We know something is an insect because it has 3 body sections. So a head, a thorax, and an abdomen. It has 1 pair of antennae, so 2 antennae on its head, and then 3 pairs of legs. So insects have 3 pairs of legs that are grouped together on their thorax. All of these traits combined makes you know that you're looking at an insect. The cockroach, the moth, the Goliath beetle, the earwig, the cicada that you see here, wildly different looking organisms, but are united by those key traits. Insects use these traits to look wildly different from each other. So I was just talking about that with that sort of rogues gallery there. Here is a series of images from Alex Wild, one of the most famous insect photographers. If you go to his website, you can see his fantastic work. But just looking here, you can see those 6 legs, those 2 antennae, those 3 body sections. You can put them together in all these different forms. We have the flower fly at the top center. In the middle, we have a milkweed longhorn beetle. At the bottom, we have a praying mantis. It's hard to conceive that that flower fly is the same thing, essentially, as that mantis on the bottom. The same is true of the monarch butterfly versus the periodical cicada. One is a black and red and orange tank. The other is this black and orange delicate thing that's capable of long distance flight. They just use these things to exist in different ways. They put these body plans together in different fashions, but ultimately it's all one united world with 6 legs. And that's an important thing. If you're looking around in the world and you're trying to figure out what you're looking at, those are the things to think about if you want to know if it's an insect. The other thing I wanted to talk about today, and this is the part where I hope Renee and Billy will stop me if I get too crazy, but I wanted to talk a little bit about how we've arrived, I guess, at this point with insects, where we have an insect week, where we have all these questions about what's happening with bugs, and we have weirdos like me that stand up and try and argue for their existence. I think that this is a long time coming, and it has to do with our distant past. If we look back, we know that our ancestors contended with insects. We know that they lived with insects. We know that because of the fossil record and other archaeological evidence. But we also know that they had thoughts and feelings about these organisms because some of them kept records that showed their agricultural practices, for example, that helped them to combat pests. We also know that insects have fit into human culture in positive ways. So these are just two examples from Egypt, one showing some cultivation. They had records showing sort of how they grew crops to try and protect them from pests. They also had insects that they venerated. The scarab beetle in ancient Egypt was considered the mover of the sun. It was a part of their hieroglyphs. You can see the hieroglyph with Khepri, the scarab god here. And they venerated this because they thought it was a key part of the natural world that was helping the sun to rise and set every day. And so we have all these different sort of ways that people feel about insects. A lot of it was negative. People have been killing bugs for a long time. The way that we know that is, again, archaeological evidence. There are things that we see sort of at archaeological sites and things that have been preserved that show us how humans have dealt with pests before. The example I have here are louse combs. You can still buy louse combs today. They sometimes come with the shampoo if you're trying to get rid of head lice. And they're essentially the same that they were 3,000, 4,000 years ago when we used to carve them a little more ornately out of wood and bones. But it's just a way to comb your hair to pull out the louse. It's also a way to comb the hair and pull out the nits so that they won't hatch on you more. This is found at almost every archaeological site. We're able to locate these. We also have other things, written records and images that people made back in the day of other pests. So here are some examples about bed bugs. I hope that this isn't to scale because this would indicate that bed bugs used to be the size of hamsters, and I can see why that poor woman feels so hectored by them. But people used to do things to try and combat this, like burning peat moss under their bed to drive out the bed bugs. We have the nursery rhyme, "Good night, sleep tight, don't let the bed bugs bite." This was something that people genuinely hoped for, was that you would get a good night's rest and not wake up with insect bites. There are other sort of written books about fleas and how to get them off and bed bugs again here. When we look at this historical pest management, though, I think what we would notice is that most of it is focused on suppression. There isn't a lot of hope for total elimination. Today, I would argue most people, when they think about pest management, they don't want any insects left after the event. They want to kill them all and kind of let God sort it out. They don't want to say, okay, we can suppress this, we can manage this. They want eradication. That modern sort of demand is a little different from where we've been, I would say, just a few hundred years ago, the way that we would have behaved in response to some of these insects. And the reason that this happened, I think, has to do a lot with the movement from Europe and other what they might call the old world continents to the new world continents in the Americas. So this is where I'm going to go way out of the beaten path, but it happened in a way that meant there were lots of things kind of moving back and forth between these areas. And this started to set the stage for, I'd say, harder expectations and sort of more interest in trying to get rid of insects. It's all kind of trickling down from this globalization that occurred. And it comes from the Columbian Exchange. So we sent a lot of things from Europe to the New World. The New World sent a lot of things back to Europe. I would say Europe got the better end of this deal. They got corn and tomatoes and peanuts and turkeys. The New World got coffee. That's cool. They got honeybees. That's all right. Livestock, not so great. Lots of diseases were brought over here as well. One of the big things that sort of made the switch in this history was the potato, though. So the potato is a favorite insect, favorite food for an insect called the Colorado potato beetle. My sort of thesis is that this is the insect on which a lot of our attitudes about insects and pests today kind of hinge upon. It is native to the United States. It's native to the central part of this continent. It naturally feeds on buffalo burr, a weed that grows kind of in the Great Plains area. It's not distantly related from potatoes. And when these were introduced to potatoes, they switched from their normal host and have completely shifted to feeding on the spuds that we grow. Potatoes are also native to the Americas. They're native from South and Central America, though. They were a part of that Columbian exchange. In the course of a few hundred years, Europeans gradually kind of forgot that they didn't invent the potato. And when they started moving more to the New World, they started bringing it with them and planting it from the eastern U.S. to the central U.S. And that's where it encountered the Colorado potato beetle. In Nebraska, this is where this started. They started feeding on potatoes, devouring all of them and destroying them. And then they gradually moved east. And as they did that, they ate more and more of the potato crop until they actually jumped on ships and ended up back in Europe. This would have been in the early 1700s, mid 1700s, and this became a very potent world-changing pest because of that. In the 1860s, this was a pest that was becoming such a problem that people were exploring options to kill it. And there were some growers in Indiana and Illinois who discovered that a paint that people used for wallpaper, it was also used in fireworks, it was used to dye dresses, called Paris green. It was also able to kill insects. It was sprayed on potato plants to kill Colorado potato beetle. You can see they actually have like a mascot to sell it here on the right. This guy that's sort of spraying things to kill the Colorado potato beetle. It works because it has arsenic in it. So it was actually toxic for us to wear it and have it in our home. It was also toxic to these insects because arsenic is naturally toxic. But this was a revolution. This was this, oh, we can spray this. We can use this as something to put on the plant and it will kill these insects. We'd had insecticides before, but they were things like sulfur and some other things. This was sort of an industrialization of that process. And it led to more things like lead arsenate, nicotine, cyanide, and kerosene being widely used for pest control. This is an image from the early 1900s of a horse-drawn applicator pumping out, I think it's arsenate of lead in this particular sprayer, but they're treating fruit trees with this. These were organic products technically. They come from an organic place. They're also highly toxic. There are widespread cases of poisonings and things like that after eating produce. Also, not very good for the environment. But it's setting in more and more this expectation that we can spray something and kill these insects that we don't want to have around. The age of these kinds of insecticides died in the 1930s when pyrethrum took over much of the market. This is an extraction from chrysanthemum flowers. It became very popular. But then by the end of World War II, we have the advent of the age of DDT. So the production of synthetic insecticides that emerged from German scientists in World War II and then were kind of perfected in the American Army. This product then got onto the homeowner market, and it became very normal to have something in your garage or in your shed that you could just go to and you could go out and wipe out as many insects as you wanted. I won't go into too much of the history of DDT for the sake of time. It was first synthesized in the late 1800s. The people that discovered it didn't know what they had. It wasn't until 1939 when a company in Nazi Germany figured out that it could kill insects. They couldn't really find a buyer in Nazi Germany. The government wasn't interested. A sample of it ended up with the U.S. Army, and they were the ones that figured out it could be used to treat soldiers. It was a big part of the campaign to take Sicily. There were lots of applications of DDT in homes there to kill mosquitoes and lice. And eventually it just sort of took over because it wasn't as toxic to people as lead arsenate and Paris green were. And it worked really quickly. There's a lot of reasons that this was so impressive to people and it became so culturally normal to have it and to use it. You can see some advertisements for DDT from the 40s and 50s and 60s here. They often feature a happy housewife who's using the product and saying how easy it is to use, how helpful it is to kill these bugs and that it protects her family. It was a wonder. It worked really well, and people still sort of think of it very positively, despite some of the other problems that it engendered. So there were lots of expectations with this. They killed mosquitoes with it. We eliminated bed bugs here in the US because of DDT, but it set, I think, a norm of if there's a bug, you can kill it. You can just spray this and it'll go away. And the consequences of that were not always fully considered. And you can see this at play today. This is still the culture that we live with. The demand from people, the consumer wants a bug-free apple. They want a bug-free home. They think that we can just do this in this zone and it won't have consequences beyond the agricultural setting or beyond your home or your apartment building. But it really does leak out and it causes problems for populations as a whole. And this attitude of all insects need to die has led to problems for them. We think of them as a plague. We think of them as something that needs to go away. This is something that's a part of our kind of dominion over nature. We are Earth's gardener. We're here to fix problems, and insects are generally thought of as problems. They're something that needs to go away. They're not helping anything. They don't belong around here, even though there's more of them than there are of us, even though they have their key roles to play. We're here to fix things, and we have the technology to do so in many cases. If you wanted to get philosophical, we could dive into the question of why we feel that way. Humans tend to make a lot of value-based judgments. Insects are kind of viewed as low-value organisms in most cultures across Earth. These insects that I showed before, a lot of people look at these. They might say, "Oh, the cicada's okay. Ah, the giant beetle in the middle, it's weird, but fine. It doesn't seem harmful." The clothes moth, though, that's got to go. The cockroach, I've never seen that cockroach, but it's a cockroach, so it's bad. That earwig has butt antlers. It looks like it could hurt me. All of these things factor into our decisions that we make about these. An animal in particular, a human, may derive value from these four traits. It's their capacity to cause pain. So can the stag beetle pinch you and hurt you? Yes, potentially. That's a negative check mark. The emotions they elicit. When I was a kid, a moth flew in my hair. I hate moths. All insects are related to moths. So negative feelings abound. I don't like that. I don't want them around. Insects are not very similar to humans, and the more similar an animal is to a human, the more we tend to value it. And then if it has some sort of use. I mentioned before how we have good insects that do things that we appreciate, and so that gets them a positive check mark. But a lot of this can lead to a decision where, well, that insect isn't valuable, and then that starts to turn into all insects aren't valuable, and we make decisions based on that. And the problem is that we now stand on the precipice of an insect apocalypse. I think I've talked about this a little bit on the show before, but we've lost somewhere in the neighborhood of either 40 up to maybe even 70% of the total insect biomass that exists on our planet. That means that there are fewer insects alive now than there were before the age of DDT, essentially. I'm not blaming DDT fully for that. I am saying that it informed a lot of the decisions that have led us to this point, which I could unpack further if somebody wants to debate. But basically, we've gotten to a point now where there are too few of them. We don't know what's going to happen next in some cases. Some of the insects that we like fireflies or lightning bugs, are in this as well, and they're suffering, and people want to know what they can do to help. But the other insects also deserve a chance at being conserved. And I don't say that just as a bug hugger, as a weirdo. I say that as somebody that doesn't want entire ecosystems to collapse. These are foundational creatures. They are needed to feed other animals. They are needed to complete their roles in the environment. And without them, things will go haywire. Things will get weird if we keep losing more and more insects. The other problem is we aren't losing the bad ones. The pests are doing better in many cases than they were before. It's the others, the neutral insects, the things that do give benefits to us, that seem to be suffering the most. So I hope that you'll take this time during Insect Week to think about bugs, to consider your relationship with them, to think maybe about what it is that you don't like about them. Are there things that you can do to confront that? Are there choices that we can make that might help their populations? Are there ways that you can join active conservation efforts, either with the Xerces Society or Operation Pollinator or the Monarch Way Station Group? Those kinds of things, they don't just help those insects, they help all insects because we're changing parts of our world to be more suitable for them. With that, I'll take off my politician jacket and get off my soapbox. I'll turn it back over to Billy and Renee. And I think we're going to hear about the tree of the week next. I hope I didn't go too far over time.
No, it was perfect. You always make me think of stuff that I never have thought of before, which I love. Yeah. And just a plug for you, because I do have on August 6th, you're coming back and going to talk about, does anything good come from mosquitoes, ants, and chiggers and ticks? So I was like,
Right.
you can talk about that, and I'm not sure, if you're going to get me on board on that one or not. But
I don't know that I'll change anybody's heart and mind about ticks and chiggers, but yeah.
Oh, Dr. Larson, that was really interesting. And, you have such a great knack of telling a great story here that's, grounded in science and what we know about things. And, I just can't thank you enough, really. I think it was fascinating to see IPM, how that came about, and, and then the impact of that and the repercussions of some of our decisions. I think here in forestry a lot, there were times that we were recommending kudzu, bush
Right.
honeysuckle,
Right.
autumn olive, right? For people to, but we've learned, we've
Right.
progressed, and we realize now that maybe some of those decisions weren't the best in hindsight. But
Yeah. Well, and we have to have a lot of grace for people in the past too. Like we can't act like we're superior to them because of those choices that were made. It was based on the best information they had available at the time. And
Mhm.
someday in the future, people will look back at us and be like, "Oh, those barbarians, those
They do it.
Philistines, what were they doing?" So, never lose sight of those kinds of things because yeah, it's a long history, and
It
we're
is.
just one piece of it.
That's right. We're only here for a little while, but I really do appreciate you and what you do for this program and really across the state. So yeah, great.
Thank you.
I don't know about comparing shrimp to insects, though. I was a little.
I'm gonna get you a
You
shirt.
didn't like
Prince's
that one,
Buds.
huh, Nate?
like that one. Someone wanted to know if there's a place where they can purchase native bugs.
There are insectaries online where you can buy things. They're not necessarily the things that maybe you are looking to conserve. They are probably native, most of them, but they're very specific things. They're things that are used for biological control most often. You could go to some science clearinghouse companies like Ward Science. They sell like moth pupa, so you could release cecropia moths and luna moths in an area. But there's other insectaries like Arbico and Rincon vitova that sell insects, and there's some that may be in their catalog that would be of interest to somebody who's planting native plants and trying to rewild an area.
Didn't know that
I,
existed.
did, I know. Yeah, I keep learning stuff all the
I
time.
was.
It's
Who knew?
great. Oh, good stuff. Yeah.
Well, thank you. Let's hear
Appreciate
about the tree of the week.
Yeah, this is an interesting one that Laurie's put together. It's the Eastern hop hornbeam we're going to be learning about. So appreciate Laurie putting that together. But big thanks to Dr. Larson. What a really fascinating presentation.
Definitely
That's it.
appreciate it. All right, let's go ahead and listen to that tree of the week.
All righty, I'll get her queued up.
I'm Laurie Thomas with the University of Kentucky Forestry and Natural Resources Extension, and I'm here with the tree of the week, the Eastern hop hornbeam. Eastern hop hornbeam, Astraea virginiana, is a small deciduous tree in the Betulaceae or birch family, and there are 3 species of Astraea that are native to North America. The common name is derived from the hardness of its wood and the hop-like fruit. It's also known as American hop hornbeam, leverwood, and ironwood. Trees typically grow about 20 to 40 feet tall and 7 to 10 inches in diameter. Hop hornbeam is considered a short-lived, small to medium-sized understory tree, and it's classified as shade tolerant. It has a rounded to oval top with fine or slender horizontal drooping branches. The tree is not typically large enough to be commercially important for lumber, but it makes an attractive landscape tree and does provide food for wildlife. Eastern hop hornbeam is found throughout the eastern half of the United States into Canada, with populations found in Guatemala, El Salvador, and Honduras. It can grow in a variety of soils, but is typically found on rocky forest and sloped areas both in the bottomlands and uplands. Where timber management is a concern, it's usually considered a weedy species. In the urban setting, it tolerates drought and heavy clay soils and makes an attractive small landscape tree. The leaves are alternately arranged on the twig and simple in form. They are oval to broadly lance-shaped, narrowing to a point at the tip. They're about 3 to 5 inches long and with doubly serrated margins. They tend to be green above and pale below, and kind of fuzzy in the axils of the leaf veins. They resemble other birch species leaves. Autumn color is yellow to a golden reddish, and leaves tend to drop early in the fall. Hop hornbeam is monoecious, which means the tree has both male and female flowers. The male flowers are preformed, typically 1-inch long catkins, and they're usually in groups of 3. They are said to resemble a bird's toes. The male flowers develop in late summer, preceding the female flowers, and are present throughout the winter. The female flowers appear in early spring and are in slender light green catkins that are less than 1/2 inch long, and the flowers are wind-pollinated. The fruit is 1/4 of an inch nutlet that's enclosed in a dried leafy sac which resembles a hop. There are several enclosed nutlets hanging from a single stem. The fruits ripen in fall and begin to break up, and seeds are mostly wind dispersed throughout fall into early winter. However, birds do provide some dispersal. Trees begin seed production around 25 years of age. The bark is smooth and reddish-brown with horizontal lenticels on young trees, and as the tree ages, the bark turns light brown and develops a shreddy appearance of loose scales or plates. The wood is extremely hard, and it has a high cutting resistance and is difficult to work. The sapwood is pale yellow and the heartwood is light brown with a somewhat reddish hue. It is rated as non-durable to decay resistance. Overall, hop hornbeam is considered as of secondary importance to wildlife. Deer only browse it incidentally. However, the buds and catkins are an important food source in the winter for ruffed grouse, and the nuts are eaten by wild turkey, bobwhite, red and gray squirrels, pheasant, purple finch, grosbeaks, and downy woodpeckers. Hop hornbeam is not a timber tree due to its size, but the wood has been used for small specialty products like tool handles, posts, mallets, wooden ware, and golf clubs. The national champion eastern hop hornbeam as of 2021 is in Oxford, Maine, where it was planted in 1812 on Paris Hill. It is 75 inches in circumference, 65 feet tall, with a 34-foot crown spread. The Kentucky champion eastern hop hornbeam is in Franklin County. It's 55 inches in circumference, 90 feet tall, with a 35-foot crown spread. If you'd like to know more about champion trees, check out American Forest National Champion Trees, or check out the Kentucky Division of Forestry Champion Trees. Now for a few fun facts about eastern hop hornbeam. The hardwood was once used for sleigh runners, and Native Americans used the inner wood to treat toothaches and soil mussels. The common name of hop hornbeam is derived from the hop-like fruits. Another common name for this tree is ironwood due to its extremely hard wood that has been known to dull the saw blade. The scientific name Austraea is from the Greek and means a tree with hard wood, and Virginiana means from Virginia. I hope you get the opportunity to get out into your woodland, local park, or neighborhood this year and enjoy our beautiful trees and maybe even get a chance to see the interesting eastern hop hornbeam.
You know, it's always really interesting to see these because she brings a lot of points out that I would never even have realized, kind of like Dr. Larson does. Certain things that, it's not good for this or it's great for that, and certain birds. I mean, it's just amazing, all these different aspects that Laurie brings into those. So we really appreciate her doing it.
Yes, big thanks to Laurie for putting those together. We'll remind folks, she has a whole segment on our website for all these common trees. So there's a lot of good content on those. But Laurie's actually down teaching Forestry Works of Kentucky at Robinson Forest today. So she couldn't be with us in person, but we do appreciate her putting that together for you all today. And yeah, thanks, Laurie.
Definitely. So, that's all we have for today, but we do appreciate you being with us, because if you weren't here, then why would we be doing this? So we greatly appreciate you joining us each and every week.
It's awesome to have so many passionate people that care about our forests and wildlife and natural resources. So thank you, really, and help us spread the word. Right, there's probably others you may know that would appreciate this content. Help us kind of build the audience, and we would thank you.
Definitely. And if you miss any of our shows, you can go to fromthewoodstoday.com and you can see all of them there. They're literally, except for today's, but that'll be on, next week. So we appreciate you being here and joining us each and every week at 11 o'clock. Until then, take care.
Thanks.
Bye.
Bye-bye.
From the woods today. From the woods today.